Okay, here we go. This is Geometry 4.1 practice problems. First three, don't overthink these. We just have to draw a picture here. So number one, we're going to draw an obtuse isosceles triangle. Obtuse meaning we have to have an angle over 90 degrees, and isosceles meaning two of the sides have to be the same length. So let's go ahead and try to make these lengths the same. We'll indicate that with these markings here. And then here we go. Okay. You guys can do the next one. Those don't look too hard. All right. 4 through 9, we just need to solve for x. Some of these are super easy. If we recognize, like number 4, these markings mean that this is an isosceles triangle, and we know that if these sides are congruent, then these opposite angles are congruent. So if this is 72, so is x. Super easy. Okay. Number 5, you guys can do that one. It's just going to be if these side lengths are congruent, you can set those two expressions equal to each other. Number 6, a little bit different. We can set it up the same way. We see that the side lengths are the same, so we can set these up equal to each other. However, we're going to have to factor with this one. So the first thing we need to do here is set this equation equal to 0. I'm going to do so by subtracting 18 on both sides. And I'm left with x squared plus 3x minus 18 is equal to 0. And now I'm going to factor it out. So I'm looking for the two numbers, right, that multiply to equal negative 18 and then add up to equal positive 3. And so you think about how many ways can I multiply 18? Well, 18 times 1, 9 and 2, 6 and 3. All right, I think we're going to stop there. 6 and 3 is going to work for us. We just need to have the 6 positive and the 3 negative. That way they add up to a positive 3. All right, and so essentially this is just two different equations, right? X plus 6 is equal to 0. How do you solve for x? Subtract 6 on both sides. Whoa, get rid of that. Subtract 6 on both sides, and you're left with x is equal to negative 6. And then the other one, x minus 3 is equal to 0. Well, you just need to add 3. Add 3. You're left with x is equal to 3. All right, so there are your two values of x for that one. You're going to have to do the same type of problem for numbers 8 and 9. So if you're struggling with factoring on there, just come see me on my Google Meet. All right, 9, 10, 11, and 12. We're just marking up these, it looks like, okay? So we're just going to see what side lengths and which angles are congruent, okay? So remember, we're going to be going from G to H to F. So G, H, oops, sorry, G, H, F. So it's got to be this one. G, H, F. Okay, right, 1, 2, 3. Okay, so that means this is the first side length, second, and then third. Okay, so now we're going to go this way as well. So G is going to be the first, H, second, and then L is going to be the third. So one's going to have 3 arcs. And it also means that if this one's already marked one, which makes sense because they're sharing that side. So of course they're the same length. Here is going to be the second, and here's the third. So basically what that means, so we know a lot from this, okay? We know that angle G are the same. We know that angle H is the same on both sides there, right? We know that angle L and angle F are the same. Ooh, I didn't put the third there. Angle L and F are the same. And then we also know these segment lengths. We know that GH is the same, HL and HF are congruent, and then GF and GL are congruent. Okay. Why don't I do one half way through and you guys can do the rest. So triangle CBD, CBD. So I'm going this way, right? That's the order. Okay. So C is going to get my first marking. We can also put our marking on the segment there as well. B is going to get the 2 arcs. Segment BD is going to get the double marks there. And then D is going to get the 3 arcs. And so the last thing is CD will get the 3 hash marks. All right, so now we're going to do the same thing over here. So JKL, J, we're starting with J, going to K, and then finishing it out, okay? So J, 1 arc, K, 2, L, 3, and we can also do the segment lengths. So JK, the side lengths, it's going to get 1, 2, and 3. All right, what do you guys give 12 a shot? Move on over here. Okay, so now we're basically doing the opposite for 13, 14, and 15. We are writing a statement of congruence, but we're going to kind of follow the same way, just in reverse. So we have this single mark to 2 to the 3 arcs. So it looks like we're going to be going from J to I to K. So triangle JIK is congruent to, we do the same thing over here, STR, right? 1 arc to 2 to 3, okay? So triangle STR is congruent to JIK. All right, and what else can we say about this? I mean, we could name these differently. Well, we just have to keep the same order. Like we could definitely go the other way, right? We could go KIJ. Okay, we could say that, right? Triangle KIJ is congruent to, now we have to go in reverse as well. We have to start at the 3 arcs, go to the 2, and then end at the 1. So we would say that triangle KIJ is congruent to triangle RTS. Okay? All right. I think you guys get that. You guys can try 14 and 15. Let's look at 16, 17, and 18. All right, so now we're just looking. So if you want to mark these fully up, we can. SUT, so we're going SUT. So this would be single, double, triple. And it looks like we're asking for the an angle measure. So we don't really need to go through and mark up our side lengths. But I can if you want. So now I'm going to look at the second triangle, triangle SCE. We're going S is the first, E is the second, and E, oops, I wasn't even paying attention. SCE, sorry, SC is the second, right, because it's in the middle. And then it ends at E, so there's the third. All right, so let's look. We're looking for angle U. So angle U has the 3 arcs. So which one on the second has the 3 arcs? That would be angle E. No, it doesn't. Okay, let's look at 16, 17, and 18. So we're just looking for specific things here. It's saying angle U is congruent to what? So we can certainly go through and mark these up like we've been doing. SUT, so we're going from S to U to T. So it looks like this could be 1, 2, and 3. And it's asking for an angle, so we don't really need to go spend the time to kind of mark up the side lengths. So let's just do the angles. So now we're going SCE, S to C to E. Okay, so S is the first one, right? And we know those are congruent because those are vertical angles. But now we're going S to C, so C gets the 2 arcs, and then E and at E, so E gets the 3 arcs. And so what's our question asking? Angle U is congruent to angle C because they both have the double arcs. Okay. Again, we could try to draw this out, but we don't really need to. So VWX, WX is right here, and this is actually for a segment length. So this is really easy here, guys. So for triangle VWX, segment WX is the last two. Okay, so then when we go over here, we got VLM. All we need to recognize is that we just have to stay consistent. So the last two would be LM. So this would be segment LM. Okay, and we could certainly take the time to actually write this out, but I think that's a lot easier to do it that way. Okay, 18, we're looking for GI. Okay, so again, I could just say GI. Well, it's going to be GH, or sorry, GW. But we can kind of prove that here. So I already know the answer is going to be GW. So let's go ahead and kind of prove this. Okay, so I'm going to start at the first triangle, so G or HGI. So we got 1, 2, 3. So that means we're going to go from 1 to 2 to 3. So this is going to be the first segment, second, and then third. And now for the second triangle, HGW, we're going H to G to W. And so GH, we already know that one's a shared side, so that one's congruent. And then the second, and then third, okay? And we see GI is right here with the 2 markings. So GW also has the 2 markings. So there we go. We showed it both ways. Okay. If you guys need more help with this, come find me. Good luck.